Well, good afternoon, everyone. Welcome back to this afternoon's portion of the Idaho Range Livestock Symposium. My name is Benton Glaze. I'm an extension beef cattle specialist in the Department of Animal Veterinary Science at the University of Idaho. And before we get started here this afternoon, just a couple of things that I'd like to say. I'd like to reiterate the thank you that Scott mentioned this morning of the committee that we put together to kind of plan today's activities. Everybody worked hard throughout the year to plan things, and we appreciate that. I'd also like to thank each one of the speakers that have been a part of the program and the ones that we'll hear this afternoon. Appreciate each one of those people taking time out of their schedules to be a part of our program and to bring us some very relevant and very informative information here today. And I'd also like to thank each one of you as participants for taking time out of your schedule to be a part of the symposium here. And as I mentioned, you as participants, will have an opportunity to evaluate today's program. We'll put a link in the chat later today. And we just like to ask you to please put your comments there in that evaluation, follow the link, do the evaluation, so that we can plan for future symposia and bring information to you that's valuable to you and that will help you as you go forward with your operation. So look for that link here a little bit later, and please fill out the evaluation. The other thing, as we have planned today, we've also, as you registered, we got some email addresses from you. Once these recordings get trimmed and put together and posted online, we plan to send out an email to you to let you know that those have been posted, so that if you'd like to go back and look at some of the information, you'll have an opportunity to do so. The other thing that I'd ask is that as we share that information with you and those presentations get posted, share the links and the locations of those recordings with your friends, your neighbors, and maybe some of your colleagues. So if they weren't able to attend today, that they might be able to access that information and get some value out of it in that regard. So hopefully you'll be able to do that. And I'm looking forward to the remainder of this afternoon and the speakers that are lined up. So with that, I'd just like to take a moment to introduce Dr. Amy Skibble. Dr. Skibiel joined the Department of Animal Veterinary and Food Science at the University of Idaho in 2018. She came from the University of Florida. Dr. Skibiel is a lactation and environmental physiology, and she studies the metabolic adaptations to lactation and impacts of various environmental stresses on dairy cattle health and production from systemic, cellular, and metabolic perspectives or molecular perspectives. Over the course of the last couple of years, she's been investigating the effects of particulates in wildfire smoke on cattle health and performance. And so this afternoon, I'm really looking forward to hearing about maybe how these wildfires that we've seen across the West over the course of a number of years may be impacting our livestock. And so I turn it over to Dr. Skibiel and look forward to hearing a little bit about fire effects on animal production. So Dr. Skibiel.
Sorry about that. Without further ado, Benton, thank you so much for the introduction, and thank you to the organizing committee for inviting me to give a talk today. I'm very excited to present some of the research that we've been doing over the past couple of years, investigating effects of wildfire smoke on animal health and production. And I want to mention this work has been done in collaboration with Dr. Pedram Rezamond at the University of Idaho. And also today, I'm going to present just a little bit about wildfire smoke effects on plant photosynthesis and crop productivity as well. Full disclosure, that is not my area of research expertise, but I think it's obviously relevant to cattle production as well. So why are wildfires a concern? I think we're all pretty well aware that wildfires are becoming more frequent and more severe in recent times. And this is exemplified by a number of high-profile wildfires that have occurred recently. So for example, the Bootleg Fire in Oregon, which burned in 2021. Also the Dixie Fire in California, again in 2021, which now currently holds the title as the second largest wildfire in California history. And if you look at the top 7 largest wildfires in terms of acreage burned in California alone, they have all happened in the last 3 years. So looking at these figures, you can see the annual number of wildfires and the number of acres burned nationally across the past decade or so. In 2020, we had about 60,000 fires and about 10 million acres burned. In 2021, it was very similar with about 8 million acres burned. And experts are predicting that there's going to continue to be an increase in the duration of the wildfire season in the Pacific Northwest and a massive increase in the wildfire area burned by the next century. I also want to point out in this figure on the bottom right, you can see there's also a predicted increase in the number of weeks with risk of very large fires. And again, you can see this very clearly on the map, occurring mostly in the Western United States. So of course, with wildfires, crops and vegetation are burned, structures and buildings are decimated. But also wildfires release a number of air pollutants that have impacts both on human and plant health. And of course, with an increasing number of fires expected in the near future, there's going to also be a greater likelihood of adverse health effects from poor air quality stemming from these wildfires. So wildfire smoke has many different air pollutants that are concerned for public health, such as ozone, carbon monoxide, there's nitrogen dioxide, volatile organic compounds, and particulate matter, just to name a few. Particulate matter is thought to be one of the most hazardous components of wildfire smoke, and I'll explain why in a minute. But just to explain how particulate matter is categorized, it's typically done based on size. So you'll hear the term PM10, which are coarse particles. These are particles that are between 2.5 and 10 microns in diameter. And then you'll also hear PM2.5 or fine particles. These are particles that are smaller than 2.5 micrometers in diameter. And of those two different sizes of particulates, PM2.5 is considered to be especially harmful. And that's because fine particulates can be inhaled deep into the pulmonary tract, where they can deposit in the lower airways and in the alveoli. And the alveoli is where gas exchange occurs in the lungs. And so PM can deposit deep into the lower airways and the lungs and impede normal gas exchange. Also, fine particulates can cross the alveoli to enter into the bloodstream to be circulated around the body and can cause systemic in addition to local effects in the lungs. Because of this, the EPA considers PM2.5 a criteria pollutant, meaning that it has established national standards for human exposure to PM2.5. But as I mentioned previously, other animals as well as plants can be affected by particulates in smoke. So just to talk in the next couple of slides a little bit about some recent work that's been done on crops. Again, not my area of research expertise, but I think it's valuable to cover nonetheless. Recently, there was a paper published by Hemies and colleagues, and they found that wildfire smoke increases the diffusion of solar radiation. So if you look in that top figure on the top right, this is showing PM10, another component of wildfire smoke, in these red dots. And then the bluish, green, and purple bars are the diffusion of photosynthetically active radiation. So this is basically the amount of sunlight that's actually diffusing across a canopy and reaching the vegetation. So you can see that when PM10 increases, there are concomitant increases in the diffusion of sunlight. So basically that PM10, or those particles in smoke, are scattering the sunlight. So more of it is reaching the plants. If you look in the middle figure, you can see on the left y-axis is the total amount of sunlight, or the total amount of photosynthetically active radiation. And again, PM10 is plotted as these red dots. And here you can see that total sunlight doesn't really change very much relative to PM10. Okay, so PM10 in smoke due to wildfires seems to not have much an effect on total sunlight, but increases the amount of sunlight that's reaching plants. And as a result, there's a greater photosynthetic capacity and higher productivity of plants when they're subjected to wildfire smoke. This is demonstrated in the figure on the bottom right, where on the x-axis you can again see the diffusion of that sunlight, and on the y-axis is light use efficiency. So particularly for corn, which is shown in yellow, and alfalfa, you can see very clearly that with greater diffusion of photosynthetically active radiation, those plants are more productive. However, there are also studies that have shown the opposite, where wildfire smoke decreases productivity and can actually induce crop taint. So there are some anecdotal reports from the Pacific Northwest that in this past wildfire season, the smoke completely decreased total sunlight, and that delayed harvest by 2 to 3 weeks. Now, take this with a grain of salt because it is an anecdotal, they are anecdotal reports. And some of that delay might have also been, and likely was, also attributed to the drought this past summer. But nevertheless, there is some substantiation from the literature. So there are studies showing that in cloudy conditions or in certain smoky conditions, those particulates can actually decrease total radiation as well, which swamps out any slight increase there might be in the diffusion of sunlight. Also, ozone, which is another component of wildfire smoke, can impair stomatal uptake of carbon dioxide, and that can have impacts on photosynthesis. And then also, there are a couple of studies that have shown that smoke compounds can interact with plant constituents, resulting in the release of volatile organic compounds that can accumulate on the plant and impair photosynthesis. So all in all, really the relationship is complex. It's not so straightforward. It might be that there are trade-offs between total light and other pollutants as well, as we saw with ozone, for example. Also, the relationship between plant productivity and exposure to smoke might not be a linear relationship. It could be that mild to moderate levels of smoke result in small increases in productivity, whereas extremely smoky conditions decrease productivity by decreasing total sunlight. And so I think the bottom line is the relationship is complex. There are competing mechanisms that can have opposite effects on plant photosynthesis and productivity. And there's really not a lot known about this. So really empirical studies are needed to not only quantify growth and productivity of crops, but also their nutritional value, palatability, and digestibility, all of which are relevant to cattle performance. And of course, if we want to get at what these relationships really look like, we have to be able to study this topic across a range of wildfire conditions. So for the rest of the talk, I'm going to focus on wildfire effects in animals because this is more my area of research. So in humans, just to give you an idea of what's known about wildfire effects, it has been shown that exposure to wildfire particulate matter increases lung disease and damage, decreases lung function, and increases hospitalizations from respiratory ailments. So if you look in this figure here on the y-axis is the percent difference, in the number of hospitalizations per every 10 microgram per meter cubed increase of PM 2.5. They also show lags of 0 days, so that is on the day of the smoky condition, and delayed or continued effects every day up to 6 days later. And you can see that very clearly there's an increase in the number of hospitalizations due to respiratory problems during smoky days, shown in the closed in symbols, versus non-smoke days, shown in the open symbols. There are also cardiovascular effects. So there's an increase in hospitalizations from cardiovascular problems like heart attacks and heart failure, and also reduced cardiovascular health with exposure to wildfire PM. And lastly, a number of studies have reported relationships between increased risk of mortality and exposure to wildfire PM. And in humans, these effects seem to largely be attributable to an inflammatory response and to oxidative stress, both locally within the pulmonary system and systemically across the body. And it's worth mentioning too that certain populations appear to be more vulnerable to wildfire particulate matter, especially the young, the elderly, and those with pre-existing conditions. There are very limited studies on the effects of wildfire particulate matter in free-ranging and domesticated animals that aren't typically used as models for human health. One such study was done with captive bottlenose dolphins in the San Diego Bay, and these researchers collected blood samples before, during, and after 2 wildfire smoke events across a couple of years' time. And what they found was that during the wildfire event and 1 month after, those dolphins had higher carbon dioxide levels in the blood, and they also showed changes in white blood cell populations, which are important immune cells. And specifically, they found that there's a higher percentage of eosinophils, which is shown in this figure here, both during and 1 month after the fire. So more eosinophils circulating in the blood. So fire appears to have effects, or fire smoke, I should say, appears to have effects on animal immune and lung function as well. There is an interesting study on orangutans also in Borneo. And these researchers found that the animals spent more time resting during wildfires and less time locomoting, even though they ate the same amount of food during and after these wildfire smoke events. Those animals entered into a negative energy balance. And this is thought to be due to a heightened immune response. And so there also appears to be effects of wildfire PM exposure on body metabolism. And lastly, this was not done specifically with wildfire, but just ambient general PM10 increases the risk of pulmonary lesions in pigs. Cattle are especially susceptible to respiratory disease due to several unique anatomical and physiological properties of their pulmonary system. And this could also make cattle even more sensitive than other animals to inhaled air pollutants. So some of these characteristics are that cattle have fewer pulmonary capillaries per alveolar section, which basically is a fancy way of saying that relative to other mammals, cattle have a lower capacity for gas exchange in the lungs. Cattle also have longer trachea and bronchi relative to other animals, which means that air is spending a longer time in the respiratory tract. And that can increase the likelihood of fine particles depositing in the airways and in the lungs. Cattle also have lower lysozyme levels and fewer alveolar macrophages, which are 2 really important components of the pulmonary immune system. So what do we know specifically about particulate matter impacts on cattle? The short answer is not much. There's a study that was done a few years ago that showed an increased risk of dairy cattle mortality with exposure to PM10. So if you look on this figure here, on the y-axis, you can see relative risk. This is per 10 microgram per meter cubed increase in particulate matter, and then lag days again across the x-axis. So with with increases in PM10, you can see that the risk of mortality increases, and that's up to 25 days later. Another study that came out a couple of years ago also showed that air pollutants, specifically ozone, increases the risk of mortality in calves. I want to point out that these two studies were looking at ambient levels of air pollutants, not specifically from wildfires. And so we know that wildfires have chemical signatures, or wildfire smoke, I should say, have different chemical signatures of air pollutants relative to other sources, such as industry or a number of things, just general ambient levels. And so it really is important to study the effects of wildfire smoke specifically, because there can be different physiological outcomes relative to exposure to other sources of air pollution. So on that vein, there was a study that just was published at the end of 2021, and they looked at both ambient sources of PM 2.5 plus wildfire-derived PM 2.5 in combination with temperature and humidity. So THI is just temperature humidity index, and found that in combination, when all of those were high, milk yield was lower in dairy cattle, and they also had an increased somatic cell count in the milk. So this was a wildfire-specific study. My group has also shown through preliminary studies where we collated data across 2 farms in the Pacific Northwest and across a 5-year period, we found that wildfire-derived PM 2.5 was associated with just general illness in cows and increased mortality among calves. What do we know about wildfire particulates and lactation? Really nothing. All of this work, and there hasn't been very much done, is just on kind of subjective measures of environmental quality and different sources of particulates. But I'm just going to explain some of what we do know. So it does appear that particulates have an impact on mammary function. So exposing rabbits to diesel particulates changes lipid and protein metabolism in the mammary gland and hence alters milk composition. So that was a pretty interesting study that was done fairly recently. There are also a couple of studies in humans, again, using these kind of subjective measures of environmental quality, which includes air pollution among lots of other aspects of the environment. And they also looked at nitrogen dioxide levels specifically and showed that either high levels of nitrogen dioxide or low subjective measures of environmental quality were associated with a lower likelihood of starting and maintaining breastfeeding in humans. So why is all of this even important? Well, as I demonstrated earlier, the Western United States are particularly prone to wildfires. And they also happen to be a high contributor to total milk production in our country. So if you look on the figures shown in this slide, these are data taken from the latest USDA statistics reports. You can see that the Western United States together has about 34 million cows. And if you look on this figure on the right, this is the breakdown of milk production in the country by region. And you can see that the Western United States altogether produces about 40% of the milk in the United States. So it really is critical to understand what potential impacts there are of wildfire smoke on cattle production and also on cattle health. And so that's what we set out to do. So this first study I'm going to present was led by my former graduate student, Ashley Anderson. And in this study, she had 7 primiparous and 6 multiparous Holstein cows that she followed throughout the wildfire season in 2020, so July through September. These cows were housed at the UI Dairy Center in an open barn with free stalls, and all of the cows calved in early July. So they were in early to peak lactation through the wildfire season. Ashley collected blood samples either weekly or biweekly for blood hematology analysis, and she also collected milk samples to assay for milk composition. And I should point out this figure down here on the bottom right is our sampling schematic. So all of the stars, all of the stars are when we collected samples. The blue stars indicate when we took an additional blood sample to assay for blood carbon dioxide levels. We also had daily milk yield from the farm management system, and we obtained hourly PM 2.5 temperature and humidity data from the Idaho Department of Environmental Quality monitoring station that was located about 5 kilometers from the farm. So as you can see in this figure, PM 2.5 levels were pretty low across the whole summer, with the exception of mid-September, when we saw a huge spike in particulate matter, and that was associated with a 7-day wildfire smoke events that were coming from Washington, Oregon, and Northern California. So this figure shows the PM 2.5 as well as the temperature humidity index, which is just an index that's incorporating both temperature and humidity. And you can see what that looks like across the summer. So THI fluctuates quite a bit, but there are relatively few days where the THI exceeds 69, which is considered to be the threshold for physiological signs of heat stress in dairy cows. And then we use a combination of PM 2.5 maps, wildfire maps, as well as wind trajectory mapping to actually ascribe these increases in PM 2.5 to wildfires specifically. So I'm going to show you what this looks like. So the top figure is AirPact 5 mapping of PM 2.5, and this comes out of Washington State University. So you can see on July 21st, which was a smokeless day, the whole region around Moscow, where the University of Idaho is all blue, showing very low particulate matter. If you look at the figure on the bottom right, this is mapping through AirNowTech Navigator, which shows the particulate matter plumes in gray. It shows the monitoring stations in these colored circles. And in the red triangles, those are active wildfires. Okay, and again, in the yellow star, there's University of Idaho, where the dairy farm is. So you can see that even though there are active wildfires burning, the particulate matter from those fires is not reaching our area. Okay, and let's contrast that with a very smoky day, September 12th. As you can see in the AirPact 5 maps on the top, particulate matter levels were incredibly high. They were actually close to 300 micrograms per meter cubed. On the bottom figure, you can see the AirNowTech Navigator maps. Again, lots more wildfires here in the red triangles, and you can see the particulate matter gray plumes are across the whole Pacific Northwest region. So then if we overlay that map with wind trajectories, we can see where the wind is coming from that we're getting in Moscow. So these wind trajectories are shown in the red, green, and blue lines here. And you can see that on this particular day, I think this was from September 16th, the wind is moving from the west across areas of active wildfires and bringing those PM 2.5 plumes to our location. So we're fairly confident that during this 7-day period, that spike in particulate matter was due to active wildfires burning to the west of us. Okay, so to get into some of our results, after we statistically control for parity and for the temperature humidity index, which have known effects on milk yield, we still see independent effects of particulate matter on milk yield. So if you look at the figure all the way on the left, when particulate matter is high, milk yield drops. And this is at a lag day of 0, okay? So on the day that PM 2.5 increases, we see a decrease in milk yield. We also looked at lags up to 7 days, which gives us an idea if there are delayed effects or if there are continued effects over time. So I'm just showing lag 7 here. There were lags every single day and the relationship looked the same. So even 7 days later, we still see that high particulate matter decreases milk yield. If you look at the figure all the way on the right, the y-axis shows the change in milk yield in kilograms per 100 microgram per meter cubed increase in particulate matter across all of the lag days. So you can see on lag day 0, so this is the day that particulate matter was really high, there is a 1.2 kilogram per cow decrease in milk yield per 100 microgram per meter cubed increase in PM 2.5. Lag day of 7, we see a drop of about 1.5 kilograms per cow for every 100 microgram per meter cubed increase in PM 2.5. And I keep harping on that because if you'll notice in these figures on the left, RPM values got up to almost 300. So really on some days, the milk loss was 3 times what is demonstrated in this figure all the way on the right. So looking at composition, it did not appear that PM 2.5 had an effect on milk composition, just looking at the percentages. I'm only showing fat and protein here, but this was the same also for lactose and for somatic cell count as well. If we look at blood hematology, this table is showing a lag of 3 days, so we don't see any effects of particulate matter until 3 days later. And all of those effects are interacting with THI. So high THI combined with high particulate matter increases eosinophil count, increases basophil count, decreases red blood cell count, and decreases hemoglobin 3 days later. There are also lags of up to 6 days in some of these blood cell counts. And not shown, there was also a negative interacting effect of PM and THI on neutrophil count with a lag day starting at 5 days later. We also found that high THI and particulate matter together increased respiration rate, but there were independent effects of PM 2.5 on carbon dioxide. As you can see in the figure here, when PM 2.5 is high, it increases carbon dioxide levels in the blood of cattle on that same day. There was also a lag of 1 day as well. So to summarize our study on cattle, we find that particulate matter has effects on milk yield independent of THI, and those decreases in milk yield lasted for at least 7 days. Milk loss was 1.2 to 1.5 kilograms per day per cow per 100 microgram per meter cubed increase in particulate matter. We see systemic changes and delayed effects of high THI and PM 2.5 on specific white blood cell populations. So we found lower red blood cell counts, which might be indicative of greater hydration status. There are studies showing that hydration can help keep the mucus lining of the lungs from getting too thick, which would be beneficial when there's poor air quality. We found that hemoglobin was low with high THI and PM 2.5, which suggests lower oxygen carrying capacity. We see higher eosinophils, which might be a sign of infection. If you recall back from the dolphin study I mentioned, they also found higher eosinophils up to a month after the wildfire. And then we also see lower neutrophil counts with higher THI and PM 2.5. And this could be suggestive perhaps of a reduced immune response or migration of neutrophils to the lungs, the potential site of inflammation. We see increased respiration rate with combined high PM 2.5 and THI, and increases in blood carbon dioxide levels with greater PM 2.5. That could be due to the higher carbon dioxide levels in the air that the cows are breathing. It could be due to lower gas exchange across the lungs as well. So moving on from the cow studies to talk a little bit about calves, it's pretty well known that there are critical windows of sensitivity to environmental perturbations. And one of those critical windows is during the pre-weaning period. And this is because during that time, young animals have immature organ systems and they have weaker immune competence. So there are a couple of studies, one in infant rhesus macaques that were exposed to wildfire smoke that showed decreased lung immune function and lung capacity during that exposure. And a follow-up study followed those animals into adulthood and found that they still had reduced lung volume and reduced inspiratory capacity. So it's evident, at least from these studies, that exposure to wildfire PM during critical windows of development can have long-term effects on physiological function. So we set out to investigate the impacts of wildfire PM specifically on dairy calves. And this work is being done by my current graduate student, Alexandra Pace. She had 15 heifers this past summer that she followed from birth to weaning, coinciding with the wildfire season this past summer. The calves were housed in individual hutches in a barn that was fully enclosed on 3 sides, and on one side had just half a wall. And you can see that in the background of this picture here. So the calves were exposed to the air conditions outside. All the calves were born in early July, and Alex collected blood samples again weekly or biweekly for blood hematology, and she also took various measures of general health, including respiration rates, heart rates, and health scores. Again, we obtained meteorological data from Idaho DEQ from the same monitoring station. And as you can see in the figure here, this past summer, we had multiple wildfire smoke events, some relatively small. So we had small spikes in PM 2.5, but then we had one rather large spike that lasted for about 4 days in mid-August. So again, just to show you the PM 2.5 and THI tracking across time. Again, THI fluctuates quite a bit, but still a few days that are below, that are above that 69 THI threshold for heat stress. So getting into some of the results, for calves, we find that both PM and THI interact to affect calf respiration and heart rates. So on the figure on the left, you can see the relationship between respiration rate and THI and respiration rate and PM. And you can very clearly see that interaction. So together, when PM 2.5 and THI are high, that increases respiration rate. On the right figure, you can see heart rate plotted instead of respiration rate. Again, you can see the interaction here. And what's interesting here is that together, high THI and PM actually pulled the heart rates higher. So there was a positive interacting effect of THI and PM on heart rate. These figures are shown at a lag day of 0, but there were also lags of up to 5 days. Looking at hematology, again, this table is showing a lag of 3 days. And we can see again that high THI and PM 2.5 together decrease white blood cell count, neutrophil count, eosinophil count, and hemoglobin 3 days later. Several of these parameters also had a lag of 0 days as well. And again, not shown, we have interacting negative effects of PM and THI on lymphocyte count with a 2-day lag. So we see that effect 2 days after high PM and THI. Looking at Caf Health Scores, this was done through the McGurk Caf Health Scoring System through the University of Wisconsin, and it's based on nasal and ocular discharge, fecal composition, and coughing, both induced and spontaneous coughing. And each of these scores range from 0 to 3, with 0 being healthy and normal, and 3 being a health condition. So we find that higher THI and PM 2.5 together increase I score with a 3 to 4 day lag. and increase cough score with a 3-day lag. So to summarize effects of PM 2.5 from wildfires on calves, we find that combined effects of PM and THI are on total white blood cell count and specific white blood cell populations, and specifically they are reduced. Again, we see lower hemoglobin. We also now see lower white blood cell counts in calves, which is interesting because in humans, exposure to wildfire PM induces production of white blood cells in bone marrow and hence elevated levels in the blood. We see elevated respiration and heart rates with increases in both THI and PM 2.5, and greater ocular discharge and greater coughing 3 days after exposure to high THI and PM 2.5. And so to give an overall conclusion of what we've done thus far, I think our results really underscore the importance of understanding how extreme weather events such as wildfires affect cattle health and performance. And studying these effects of smoke inhalation, we're hoping in the future can aid in improving management strategies to help prevent some of these climate change trigger deficits in productivity. And with that, I would like to thank sources of funding, the college and the department at the University of Idaho, the farm management and staff, without whom this research wouldn't be possible, the number of graduate students, undergraduates, and research technicians and specialists that helped with this project all made it possible. And with that, I hope I might have some time for any questions.
Thank you very much. I appreciate that. So there was one question that came in. It said, is there any relationship on PM10 and an ET factor?
Sorry, PM10 and an ET factor?
Correct.
I'm not sure I know what an
from
ET
the beginning
factor is.
of your talk. That's what was listed in the question. I think that was from the beginning of the talk. Maybe envirotranspiration. Did you mention that early in the talk, maybe during the plant part?
I'm not sure what that effect is. What I presented was on sunlight diffusion. I'm not sure about evaporation.
Okay.
Yeah.
And then you mentioned that maybe this will lead to some management factors or management strategies.
Mm-hmm.
You have some ideas of what type of management strategies might come about to mitigate impact of smoke or maybe other pollutants?
Yeah, that's a great question. I think one of the most obvious ones, and this is a lot easier to do for some dairy farms than it is for range cattle, right, is to have cows in maybe a semi-enclosed barn so they're at least partially sheltered from ambient air. So that's a possibility. We still need some studies to see, if that is of benefit or not. And obviously that comes with expenses as well. I think some other strategies maybe are going to have to rely less on management and more on trying to target what that particulate matter is doing in the lungs to try to mitigate maybe whatever physiological effect there is. It's really hard to say. We're hoping that we can give producers some idea of how they can prevent or get their animals through these really smoky conditions without having a ton of data right now.
And then it was asked, would you be able to share the website resources where you got those smoke maps as well as the PM 2.5 maps?
Absolutely.
Okay.
Yes. How would you like me to share that?
You could send them to me.
Okay.
And we'll get them out to everyone, or if it's easy, maybe in the chat. Either way.
Okay, will do.
Okay, thank you very much.
Thank
Appreciate
you.
that. So